fellow scientist and mathematician. Welcome to my YouTube channel, which focuses on mathematics and science. Welcome, and let us learn together, whereby mathematics is simplified together with the physics from the fundamentals, so that every person can learn and understand the rules step by step. My channel name is Luke Aaron 1. Welcome, and let us learn together. Welcome, my dear mathematician and scientist. We want to look at implicit differentiation. For example, when you have x squared plus y squared is equal to 1, one of the way of differentiating it is to make y the subject of the formula. How do we do that? We take x squared, the other side here. So x squared, we take it the other side, so it will be y squared is equal to 1 minus x. Then we take square root. Both sides, square root of y squared is y, and this one square root is bracket 1 minus x squared power half, means it is the square root. Then from there, we use power rule to differentiate, whereby the power rule tells you, you just take the index, this negative, the index here from here, the power, you bring it in front, then you keep whatever is inside the bracket constant, then you half minus 1 is negative half, then you differentiate inside, what the function inside. So 1 differentiated is 0 minus 2 differentiate 2x squared differentiated is 2x. So that is why I'm multiplying here with the minus 2x there. Then this 2 and this will cancel, and we are going to be left with negative x bracket 1 minus x squared power that. So we can take this index, which is negative in the denominator, to make it positive. Negative x over bracket 1 minus x squared power half. But we know from here that y is equal to this part in the bracket here. Y is equal to 1 minus x, or y is equal to square root of 1 minus x. So you can substitute this with y. Alternatively, we can do the same using what is called implicit differentiation. Implicit differentiation is applied where it is not possible to isolate the variables. So 2x squared differentiated with this to x is 2x plus 2y dy dx. 1 differentiated is 0. Then from there we take 2. We take 2x the other side. When we take 2x the other side, it will be 0 minus 2x, which is negative 2x. Then we differentiate by 2y to be left with dy and dx. So negative 2x divided by 2y, 2 and the 2 will cancel to be left with the negative x over 2, which is the same as the one we have obtained here. So where it is possible to separate the variables, you can use the power rule, or you can use the chain rule, so that you differentiate implicitly. But now, in real life, implicit differentiation, it is applied whereby it is not possible for you to separate the variable. So there are situations whereby it is not possible to separate the variables. For example, here, x squared plus xy plus y squared is equal to 1 over 16. Is equal to 16. In this case, it is very difficult for y to be separated. So it is difficult to make y the subject of the formula here. So when we are differentiating such a situation, that is where now we make use of implicit differentiation. We apply the implicit differentiation. So the first here, differentiated, x squared differentiated will give us 2x plus, here we apply product rule. So we differentiate x as with respect to dx, as we keep y constant. So x differentiated is 1 times y is y, plus we keep now x constant, x, we multiply by y differentiated. Y differentiated is 1. Then we multiply by dy dx. So y prime stands for dy dx in this situation. Plus, here we use power rule, 2 times y, power 2 minus 1 is 1. Then we multiply by y prime. Y prime stands for dy dx. So 16 differentiated is 0. Then from there, we factor y prime here. So y prime factored, we will be left with x plus, here y prime factored, it is 2y, which is equal to 0. Then from there, we take 2x plus y on the other side of 0. So you have 2x plus y minus 0, which will give you negative 2x plus y. Then we divide by this part here, x plus 2y. So we divide by x plus 2y. So y prime differentiated is equal to negative 2x plus y divided by x plus 2x. Note here that the value of this part, it is negative because we took with 2x plus y. So this part is negative all of it. If you want, you can leave it that way, or you remove the bracket to get negative x minus y over that. That is negative 2x minus y over x plus 2y. Or you can factor the negative outside to have what I have here. Negative 2x plus y divided by x plus 2y. So another example, I have given you another example here. Y squared plus 2yx plus 3 is equal to 5x. So we have to differentiate this. So to do that, we start here. This will be 2y y prime, or dy and dx, plus y differentiated will give us 2. Then y prime, 3 differentiated will give us 0. 5x differentiated will give us 5. Then from there, we factor y prime here to be left with 2y plus, when we factor y prime there, we will be left with y, which is equal to 5. Then we divide both sides by 2y plus 2. Another example is like this, y is equal to 1. So the first method, we can isolate x, we divide both sides by x to get y is equal to 1 over x. 1 over x can be written as x power negative 1. Then we use power rule to differentiate. So y differentiated is y prime with minus this negative here. Then we subtract minus 1 minus 1 is negative 2. X differentiated is 1. So here we have 1, here we multiply by 1. So which we can write it this way. Negative 1 over x squared. So that is the derivative. Alternatively, we can do it implicitly, whereby we apply now the product rule. First of all, we own y constant, we differentiate x with respect to dx. So here we will be left, x differentiated is 1. 1 times y is y, plus we own the x constant as we differentiate the second function. So y differentiated is 1. Then we multiply with dy and dx, or y prime. Then from there now, we take y the other side. So this implies that xy prime is equal to 0 minus y, which is negative y. Now we can divide this by x. So divide both sides here by x to be left with, which implies that y prime is equal to negative y over x. But from here, y is the same as 1 over x. Y is equal to 1 over x. So instead of y, we can write 1 over x. That is why now we have here x squared. Another example is this, whereby we are given y squared plus y squared plus x squared is equal to 25. So we can differentiate this implicitly. This is 2y prime plus
2x, which is equal to 0. So 2y prime is equal to negative 2x. So y prime is equal to negative 2x divided by 2y, which is equal to negative x over y. There is another way we can do the same. First of all, you can begin by isolating y squared is equal to 25 minus x squared. Y squared is equal to 25 x squared. We take square root both sides, power half. Taking square root here, we take square root both sides. Then from there, so we have y is equal to 25 minus x squared power a half. So we differentiate y prime is equal to a half, 25 minus x squared power negative a half multiplied by 2x. Yeah, so we differentiate this, so we bring a half forward times 25 minus x squared power negative half, because it is power half minus 1, which is negative half. Then we differentiate the inner function. This is 0 minus 2x. So here we have negative 2x. So negative half times negative 2x multiplying by this. This is power negative half. So this and the 2 will cancel to be left with the negative x over 25 minus x power half. Now negative x over, because y is equal to this part here, the part in bracket is equal to y as shown there.
So much for watching this study. Kindly like, subscribe so that you won't miss any single video which I upload now and then. Also, you can make a comment there. You can suggest any area of study which you would want me to address, and I will be more than willing to tackle it on your behalf. Thanks so much for your support, guys.